Alright, since functions are rules that convert inputs, typically x values, into outputs, which are typically y values, it makes sense they must have their own notation to indicate what the rule is and what the input is and what the output is. Let's go. In the first exercise, let's look at these for letter A. What it's saying is you are plugging, so like in the last one where I did f of 50 in our last lesson, we're doing the same thing. This is just telling you what number that you're putting in for x each time. So the first one, f of 2, means instead of 3 times x, it's going to be 3 times 2 plus 7. Well, 3 times 2 is 6. 6 plus 7 equals 13. So f of 2 is 13. Then we need to find f of negative 3. So 3 times negative 3 plus 7. 3 times negative 3 is negative 9. Negative 9 plus 7 is negative 2. So f of negative 3 for 3x plus 7 is negative 2. Same thing, you'll notice for letter B and the two inputs below it that they say g. That means you need to use the equation that has the function for g. Like letter A had f for those functions and letter C has h. So it's kind of just another way to differentiate between the different functions. So we're going to plug 20 in. So 20 minus 6 over 2. 20 minus 6 is 14. 14 divided by 2 is 7. And 0 minus 6 over 2, so negative 6 over 2 is negative 3. And just like any other lesson, feel free to pause at any point to try them on your own. This is the square root, so that means you need to find the square root of 2 times whatever x is. So 2 times 4 plus 1. So it's going to be square root of 8 plus 1, which is square root of 9, which is 3. And our last one for 0. So 2 times 0 plus 1 is going to be 0 plus 1, which is square root of 1, which is 1. So the function notation can be very, very confusing because it really looks like multiplication due to the parentheses. But there's no multiplication involved unless it is in the actual equation itself or the function. So the notation serves two purposes. 1, to tell us what the rule is, and 2, to specify an output for a given input. So the output is always your y, and the input is always your x. So let's look at this function. So we're going to explain first what the function rule does to convert the input into an output. So it's the same thing that we did before. The function rule is saying that you're going to first divide by 3, then add 7. So we're going to evaluate f of 6 and f of negative 9. So f of 6, first you're going to take 6 and divide it by 3, then add 7. So 2 plus 7 is 9. Then we're going to find f of negative 9. So first we're going to divide by 3, then add 7. So negative 3 plus 7 is 4. So find the input for which f of x equals 13. So this is saying what input will have the output of 13. So really all you're doing is you are taking that 13 and putting it in place of the f of x. So in place of the y. So 13 equals whatever the input is divided by 3 plus 7. So just like we've done before, we're going to work backwards from what we were given. So 6 equals x over 3. Then we're going to multiply by 3. So 18 equals x. So we'll know if it's true. 18 divided by 3 is 6. 6 plus 7 is 13. So if g of x equals 2 times f of x minus 1, then what is g of 6? So what this means is you're going to take, notice how they both have x. The difference is what the function is. So g of 6 is going to be 2 times f of x. Well, we have to use the f of x from up above, which is x divided by 3 plus 7. So 6 divided by 3 plus 7. Then we take that answer and subtract 1. So when it has f of x within g of x, it's saying that you're taking the function from before and putting it in place of that f of x. Really, really confusing, I know, but hopefully the more you do it, the easier it'll become. 6 divided by 3 is 2. Then 2 plus 7 is 9. 2 times 9 is 18. 18 minus 1 is 17. So g of 6 equals 17. So remember that you should start to become familiar with function rules as equations, graphs, and tables. The next few, we're going to try all the forms. So boiling water at 212 degrees Fahrenheit is left in a room that is at 65 degrees Fahrenheit, and this begins to cool. The temperature readings are taken each hour and are given in the table below. In this scenario, the temperature T is a function of the number of hours H. So the input is your hours. So each hour is going to give you a specific output. So it's saying T of 2. So notice how H is T of H, and then H is your input. So T of 2, all you have to do is you look at the table, you find where 2 is the H, and T of 2 is 104 degrees. Then we find T of 6, so T of 6, and we find what T is at that point, and it's 68 degrees. Then it says, for what value of H is T of H 76? So that's saying, what answer is 76? So we're looking, and I see a 76 right here, and we want to know what H is. Well, that's T of 4 equals 76 degrees. So between what two consecutive hours will T of H be 100 degrees? So I'm looking for when it's between what two consecutive hours will it be 100 degrees. So you need to find the one that's slightly above 100 and then the next one. So if I look here, I have 104 and 85. So that means that it will be between 2, T of 2 and T of 3. I know that because it's slightly above 100 and then it's the next one below 100. The function of y equals f of x is defined by the graph shown below. It is known as piecewise linear because it's made of straight line segments, but there are different pieces to it. So f of 1, this is saying, so remember x is what we're looking at when it gives you the number within here. So when x is 1, what is y? Well, y is 4. Then when f is 5, 1, 2, 3, 4, 5, y is negative 2. When f is negative 3, y is negative 4. And when f is 0, y is 2. So solve each of the following for all values of the input x that make them true. So we're looking at 0. So at 0, 0, so if I were to erase all of these again, at 0, 0, when y is 0, I look here, here, and here. When y is 0, x is negative 1, 4, and 7. That is the solution set, so I'm going to use my solution set symbols. And then we need to know when is y 2. So I'm going to go where y is 2. Y is 2 here. Y is also 2 here. So y is 2 when x is 0 and 3. What is the largest output achieved by the function? Well, the largest output achieved by the function is 4. And that is when x is 1.